the part of the Arrhenius equation, right? Now the Arrhenius equation, you have to know that you know what? Can we find out the relationship between what does the rate constant, rate, and the temperature, right, and the activation energy hasn't, right? Can we find out the relationship? Can we find out
Yeah.
the relationship? So how do it? See, if we see that when we increase the temperature, right? When you increase the temperature, right? When you increase the temperature, what happens? The rate increases, right? Isn't it? Understood? Rate is equal to K,
Yeah.
constitutes the part of A. That's the thing. Now, if we increase the temperature, the rate increases. We know this. Understood? If we increase the concentration, the rate increases. If we increase the surface area, the rate increases. That, but we focus on the temperature now, right? If we increase the
Yeah.
temperature, the rate increases. We know. But can we
Yeah.
know exactly who influences it? See, there are two factors which are there, right? If we increase the temperature, see this, the rate increases. So, in order for the rate to increase, either K should increase or A should increase, right? Clear? Or both should increase. Agreed. Understood this point.
Yeah.
Or both should increase. You get my point, right?
Yeah.
Understood. Both should increase, right? So it's a very important point we have to learn, right? Understood. Now, going to this
Yeah.
thing, we have to understand that if we increase the temperature, rate increases. Now, see, when you increase the temperature by 10 degrees centigrade, does the concentration change or increase? No, no. The concentration won't
No.
change. The only factor which increases is what? The rate constant, right? Clear? So we
Yeah.
can tell that as we increase the temperature, what happens? The rate constant actually increases. So the rate constant is temperature dependent. Is it clear?
Yeah.
And there's some questions you have to understand in a board exams. The rate constant, now write down rate constant increases, it increases, we know. Exponentially, write down, right? Exponentially with temperature, write down, right? Clear? Clear?
Yeah.
You get my point? The rate constant increases exponentially with temperature. Did you get my point, right? Get my point? It increases. But how does it increase? Increases exponentially with temperature, right? Now, Ola, now see, now can we find out a relation between the rate constant and activation energy? Can we find out? Yes. Let's see. How do you
Yeah.
find out? Suppose we're taking two reactions, right? Two reaction. One is having a lower activation energy, right? And another reaction B, it has got a higher activation energy, right? Right? Understood. Do you get my
Yeah.
point? A higher activation energy. Right? EAB, this is EAA. Can you tell me which reaction will be influenced more, rate will be influenced more if we increase the temperature, reaction A or B? You get my question? We have got two reactions. One where the one is having the lower activation, one is having the higher activation, right? Can you guide me?
B
Which
would
reaction will be
A would be influenced more.
think. In A,
Mhm.
what happens? Maximum reactant molecules have already crossed over it, right? Crossed over because of the lower activation age, right? Prior to the temperature increase, see, already crossed over. But in B, what happens? Maximum reactant particles could not cross over the hill. Few will be over here, right? So if we increase the temperature now in this condition, where will be influenced more? Here.
On B.
Understood? Because maximum reactant particles cannot cross the hill, right? Is it clear to you? Right? Understood. So we know that temperature, if you see, right, temperature, if you see, will be influencing more for those reactions rate whose activation energy is higher, right? Clear? Understood? Clear? Do you
Yeah.
get my point? So any reaction, if the activation energy is more, the rate of the reaction will increase more. Did you get the point? This clear? Now,
Yeah.
one scientist called Arrhenius, right? He amazingly had joined all the parameters, right? Right, by a very good equation. What's the equation? K is equal to A to the E to the power EA by RT, right? Clear? Understood? Do
Yeah.
you get my point? This is the Arrhenius equation,
Yeah.
right? Now, in your question, past paper will seeing the lots of questions are from the Arrhenius constant, right? This, right?
Yeah.
Understood? K is what? Rate constant. E is the activation energy. T is the temperature, right? And R is the
Yeah.
gas constant, right? So
Yeah.
what is A? What is A? A is called the Arrhenius constant. What does it take care of? Please tell me. What does it take care of? It takes care of the energy requirements
Uh,
of the reaction. Second, energy of the collision, right? You take out the energy of the collision. Most important. Second, It takes care of the geometry of the collision, right? Clear? Understood? What does Arrhenius constants take care? Please tell me. Tell me. Energy of the collisions and geometry of the collisions, right? Clear? You get my point?
Yeah.
Can you hear me? Now, can you do this
Yeah.
question quickly? This question quickly. Tell me.
Which one? Okay.
Okay, you do this. You do this, right? This one.
Okay. Maybe that.
We are saying what the rate constant of a reaction increases with temperature. Yes. The increase in temperature decreases the activation age of reaction. No. Right? Nothing can affect the activation age. You can write down. Nothing. No power of the world can then change the activation age. Right? Do you get my point?
Yeah.
Right? Catalysts, they will don't decrease the activation age. Right? There are many. When I check the board papers, I see that many people are writing that catalyst lowers down the activation. No, catalyst provides an alternative pathway the lower activation. You understood? Alternative pathway the lower
Yeah.
activation. Remember this thing, right? The term A relates to the energy requirements. Just I told you, no, of the collisions. Yes, wonderfully done. So what does A refers to? Tell me. Collision geometry. Yes, right. So the rate of the reaction increases with increasing temperature. This increase of the rate of the reaction is due to what? Increase in collision rate. Yes. Increase the activation energy. Nothing can change the activation energy of the world, right, or the universe, right? Increase the rate
Yeah.
constant, yes, right? Now see, we're going next part. We're going to the part of the Arrhenius equation. We are going, right. We are going to the improvised part, right? See, we know that k is equal to a e to the power ea by rt, right? Isn't it? So we are trying to writing down this. If we see that if we do ln both the sides, right, we are taking k is equal to a minus ea by rt, right? Suppose we are taking this, right? Now over
Yeah.
here, you have to understand that if you see that whenever we are seeing this reaction, right? This is the Arrhenius equation we're getting, right? Understood?
Yeah.
Now what we're doing, we are doing ln both the sides, right? We are doing ln the both the sides, right? Ln k
Yeah.
is equal to ln a plus ln e to the power minus ea by rt, right? Clear? Understood this part, right? Hmm?
Yeah.
You to get this part clearly, right?
Yeah.
So this is a very important part you to know. Now next is that
And
if you
then
see if you,
ln
this
E
this
becomes a
yeah
one,
yeah yeah
right?
yeah 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 ln k is equal to minus ea by r into 1 by t plus ln a. Is it clear? Understood? So see,
Yeah.
this is very similar to this equation, right? Y equal to mx plus c. Understood?
Yeah.
What is m? M is minus ea by r. The gradient is this, right? Isn't it? So if we plot ln x, right? If you plot ln x, if you plot ln x hmm, by 1 by t, see 1 by t, right? Understood? Did you get my point, right? We'll
Yeah.
be getting what? We'll be getting this different values we take. We change the temperature T1, T2, T3. We are getting K1, K2, K3, right? Isn't it? Fine. Did you answer this part, right? Now going to this part,
Yeah.
if you're seeing this reaction, right? Y is equal to mx plus c. Hmm. And
Yeah.
m is what? M is the gradient. See? This negative gradient, right? Gradient is decreasing, see? So gradient will be negative, right? And
Yeah.
how to find how to find out this gradient? Uh, this per delta
Delta
k
ln K
ln k by
and
delta 1 by
delta
t.
ln. Yeah.
Hmm, understood. And whatever the gradient will be equal to what? Minus A by R. And since it's a negative gradient, it will be minus gradient. Minus sign will be coming, right? So minus gets cancelled out. Understood? So gradient
Yeah.
we are taking the gradient, we multiply it by the R, we get what? EA, right? Is it clear?
Yeah.
Hmm? Makes sense over here? You
Yeah.
get my point? Anything
Yeah.
question, please tell me. Clear?
Yeah.
Hmm? So this is the thing we have to master now, right? Got it? Hmm?
Yeah.
Now, if we, so just remember one thing. If you take the gradient, right? If you take the gradient and multiply by R, R is what? Tell me. R is what? Universal gas constant, right? 8.31 joules. Multiplying this gradient by R will be giving you in joules, right? But
Yeah.
activation energy, what's the unit you have to take? Tell me. kilojoules, right?
Is it, yeah,
Kilojoules.
kilojoules.
You have to divide by 1000 to make the unit kilojoules. Is it clear?
Okay.
Ola, is it clear? You get my point?
Yeah.
Hmm? So that's the thing you have to master, right? Also, right? Clear? So
Yeah.
see, this is there's a simultaneous equation also, isn't it? This simultaneous equation that ln k1 by k2 is equal to ea by r, right? See, in this graph, right? There's a very pain, right? It's a huge pain. We have to plot different points, right? Understood this. If we have taken different temperatures, see, we have to plot the different rate constant, right? Understood. So can we take two trials of temperature one and measure K1 and take temperature two and measure K2? Can we do it? Yes, we can, right?
Yeah.
How do you do it? We by this equation we take, right? In this equation. Can you see this? We're taking
Yeah.
this equation, right? Hmm? Get my point? We're taking this equation over here, right? Fine, isn't
Yeah.
it? This will be given in the data booklet also, right? So simple. But remember one thing, one thing I want to caution you. T should be in Kelvin. This thing you take care of, right? Many people take degree centigrade directly and add it. No, it should be in Kelvin, right? Clear?
Yeah.
Because the
Yeah.
R is the R is the universal.
One
Tell me.
one thing with that, converting, it's obviously 273.15, you add that.
Yeah, yeah, yeah,
But sometimes it's sometimes will I only have to add like 273, or will it not really
yeah.
matter?
273. You can tell, right? No worries, right? You don't have to worry. You
So
can add
add
273.
like the 0.15 doesn't matter.
Yeah, point 0.5. If you see, if you take, you can take 0.15. That will be better and safer, right? See,
Yeah.
in this book also, there are some portions I want to show to you. Let me check. Oh no, they have added 273 directly. Hmm. I told you, in this book I've seen many. See, you
Yeah.
see this? They've added 273 directly, right? Don't worry, 273 is fine, right? Clear? I just want to say that mistakes over here, right? This thing you have to take part. Activation will be coming joules. Divide by 1000, right? To get kilojoules, right? Clear?
Yeah.
So that
Yeah.
was all about what? That was all about Arrhenius equation we get, right? Arrhenius equation um, of the kinetics HL portion of chemistry IBDP, right? So mm, you did the questions also. You did the questions also. You can solve this now, right? Easily. See this question you got stuck in. See, fine. See temperatures by luck, good luck, given in Kelvin only. So you don't have to add anything, right? You get my point,
Yeah.
right? Hmm.
Yeah.
Fine. So that's it.